Okay, we start in English now. So this will be helpful for the next homework, the homework 4. And I'll be showing the solutions of the next, the previous TA. And in the previous TA, I talked about this very difficult example about trying to predict if a person can do a backflip based on the hours of training. And I was talking about this function here that is the sigmoid that maps this variable u, that can be whatever, in this case is the number of hours of training, and maps that variable to a probability. And then what we're trying to do is to maximize this optimization function. And the solution of that, well, this is the data. Let me run that cell. The data is, here you have some points that are per a lot of people doing different hours of training, and if they are in this part here, they cannot do a backflip, and if they can, they are here. And basically what you need to do is to minimize this function that is the same, exactly the same as the one in the activity. But as you can see here, one tiny detail is that instead of using the logarithm, I don't remember exactly the name of the function, but the sum of the logarithms, this one here, log sum exp, instead of doing that, I directly used a function that CVXPY has that is called logistic. And what it does, you can see it when you have the help of the function, and you can see here that you have the logarithm of 1 plus the exponential of the variable. That is exactly what we want to do. So this with this function you can skip a step basically. And if you do that and run this function, this is not showing correctly. Let me open it again. Yeah. So our blue points were the data points that we had. This obtained model is the yellow line, and the prediction if the person can or cannot do a backflip is this stars in green. So with our model, we can predict very accurately if a person can do or cannot do a backflip based on this variable u. This is very important in medicine to predict, for example, if a person has or has not a disease based on some biomarkers or other stuff like that. This is very commonly used in medicine. And the other example was to try to do the least squares problem with the CVXPY library instead of just using the direct solution with the least squares function. And here I have our previous example that is not showing because this is too okay. Then you had your number of basis functions, the amount of noise, and here you have the solution in yellow and the data is in blue. And inside here I'm showing that I'm using the least squares function from NumPy. But you can do the same, but in CVXPY. And to do that, I had a problem the last TA, I'm not sure if you remember, but the only problem was that I was using the norm, and I'm not sure why, but the CVX Python library was not capable of solving just the norm, so I needed to add a square here, and now it's working. But it's basically what you expect. You use the norm, you square the norm, and you have your matrix A that represents the model multiplied by the vector of coefficients B, the vector of coefficients X, and you try to make it very close to your data B, and you solve your problem, and basically you obtain the same solution as before. Now, we wanted to have a solution, but we are using a regularization, that is the Tikhonov regularization, where we are penalizing if the weights are too big. If we do that, it's just adding this part here in the minimization problem, lambda times the norm of the weights squared. And if you do that, you obtain the solution of the problem. And you can see here that the coefficients in blue are the coefficients without the regularization. And with the Tikhonov regularization, you have the coefficients in yellow. And you, at the left, see that you have very similar solutions, but the coefficients are very different. And actually, in the Tikhonov regularization, you have lower values of the coefficients. And that makes sense because we are penalizing by the value of the weights. So this regularization term, what it does is to smooth the coefficients to make them smaller. This is very used in machine learning, for instance. And another type of regularization is to use the L1 regularization. And if you do that, you obtain something very similar, but instead of smoothing the coefficients, you reduce the amount of coefficients that are not zero. So these coefficients here are all zero, but you have a few coefficients that are non-zero. And basically what you needed to do is use the norm, but instead of the L2 norm, you use the L1 norm. And you can do that by using this argument in the function here. But everything else was the same. Okay, so now we start the second part, where we'll see about the constraints, linear constraints. And linear constraints are important because many problems can be defined using them. For example, this problem is a typical problem where you need to find the optimal route to go to all the houses. For example, this could be the Chile Express route planification, and you need to go to all the houses, but just go one time to each house, and you need to do it in the less time as possible. So you can do it by modeling this problem as an optimization problem with linear or with the linear constraints. And why the linear constraints are important? Because if you have these two types of linear constraints, the equality linear constraint and the inequality linear constraint, you can define a region, if you have inequalities or equalities, which satisfies some particular properties. Anyone knows which property has this region here? You saw it in class, right?
Is a convex region.
Exactly. As this inequality is convex, well, this inequality and the equality also is convex, and you add a lot of them, the intersection of these regions, as all of them are convex, is also convex. So the linear set of inequalities or equalities define a convex set because the intersection of convex sets is also convex. This is a property. I'm not sure if you saw this property, but this is a very commonly used property in optimization. And what happened when you had a linear, a convex set and a convex function? You saw that in class? Why we wanted to have a convex problem? For example, Daniel, do you know why it's a good thing to have a convex problem?
I have no idea.
No idea. Javiera, do you know why it's important to have a convex problem?
Not really.
No.
Uh,
Someone remembers, for example, Benjamin?
The solution of an optimization problem is in one of the, how do you say, arista? The sides of the
edges.
Of the complex area.
Yeah, that's true, but that's true only if the function is linear.
Ah.
Or
True.
no, it's yeah, only if the function is linear. Because if the function is linear, you'll always have the solution in these vertex points of the set. But the more important thing about having a convex problem, by the way, means that you have a convex set of restrictions, and also you have a convex optimization function. So for example, if we are trying to solve the problem, minimize the norm of x, that's a convex function, subject to this region. What you have is a convex problem, and by having a convex problem, if you find a local minima or a local minimizer is the point that minimizes the function. If you find a local minimizer, you are sure that this is also a global minimizer. That means that if you find a point that is the solution of a local minima, that means that you just found a solution, a valid solution to the problem. If your problem is convex, you can ensure that that point that you just found is the solution for well, basically all of the places in the problem. So if you find just one solution, you're sure that that is the solution of the whole problem. That's the main thing about the convex problems. And linear equalities and inequalities, as they are convex, are quite good in that scenario, because if you find a solution, you can be quite sure that that's a global solution of the problem. So now we'll start with an example of a problem with linear inequality constraints. That is a very complicated problem, but let me explain it a little bit. The problem is the total variation in painting. And basically what it does is to minimize something that I have not defined yet. That is the total variation of a variable x subject to a linear constraint here. And the total variation, you can think of it as a derivative of the sum of the norms of the derivatives. So if the derivatives are too large, you don't want those solutions. And just to put in perspective to the problem you're trying to do now, for example, this is your solution, this cat. This is your data, a corrupted image of the cat, here with some text overlaid. And you have a mask, U, that is basically all the points that you're sure that that's the data of the true image. And this mask here, where you can see the letters, are the parts that you want to complete with the missing parts. So going back to here, what you're trying to do is minimize the total variation, or the measure of the derivatives of your image, subject to that your obtained image is the same as your data in the points where you're sure that you have the information, or this area in white. Okay, so that's the first activity. This TA will be a little bit short, so we'll have only 2 activities. This is the first one. And yeah, let's just divide in 2 groups and start this. But before starting, someone has a last question about this? Do you understand the problem? No? Yes?
I didn't understand very well, so could you please repeat or explain again?
Okay, so basically, what you want to obtain is the image of this cat. But for some reason, someone give to you the image of the cat, but with this corruption. That is basically letters above the image. But you want to restore this image to obtain the one of the left, right? That's the problem here. And how do you do that? With the linear constraints, you need to define a region here that is called U. There is a mask in which all these points in white are the points that don't need to be fixed, but all these points in black are all the points that need to be fixed to acquire the real image that is this one. And that can be solved by minimizing the total variation of the image, subject to that the mask multiplying your solution is equal to the mask multiplied by the data. And basically what you're talking here is that you need to preserve the data in the parts that are not corrupted. And to do that, you'll need to implement a function in CVXPY, and the total variation function is already defined, so you don't need to do that, but this is the definition. And I also gave you some other hints that you need to do to solve the problem, but this is a very quick problem. I'm not sure if it's more clear now, but basically you need to define an image, X, and you need to minimize the total variation, cp.tv, of this variable, and with constraints that are this mask U multiplied, cp.multiply, with your variable, and that needs to be equal to the same cp multiply U and your data Y. And you don't need to define this X, well, you need to define the X, but the Y and the U are already defined in the notebook.
About that, Carlos,
Mhm.
the code of the exercise, the activity, has a U\origin in the code.
Sorry, I didn't quite get that.
When I ran the code to get the image, it says that origin, is not defined. There's a variable that you add to the code that is not defined.
You?
In the activity. No.
Oh, because maybe because you need to download these images?
No. It says you put U\orig point shape, and it
Let me
says
see. Oh, okay. This is incorrect. This should be Y.
Okay.
There. Yeah, sorry about that. Okay, I'll create 2 groups and let's start with the activity.
Okay.
Ah, ya caché dónde dijiste tú.
Era esto.
Hay que, sí, estoy cambiándolo. El
X.
X.
Y había que cambiarlo por Y.
Solo Y.
Sí,
Y
solo
punto.
Y U core, Carlos.
That should be Y. Sorry, I changed the variable names and I forgot.
No sé dónde está este. ¿Este tiene que ser cuál?
Y.
In shown X1. In shown.
Ahí está.
Perfect.
Ya, entonces es pasar un problema de minimización. Agregar código. Me molesta tanto trabajar en un notebook. ¿Alguna idea de cómo empezar?
Pero a mí no me corre. A ver, espérame. Ya, pusiste las dos imágenes. el link. Y después, lo único que cambiaste fue el I.
O sea, primero
el
que
otro
nada
I.
corrí de acá, que básicamente es descargar las
Sí,
imágenes.
sí, también lo hice. Ya las corrí.
Ujú.
Y ahora ese mismo.
Y agregué esta línea que básicamente definió PLT.
Ah, ya. Ya.
Que creo que lo definiste, Carlos, más arriba y por eso import from map.lim.
Claro, si llego y saco la línea no me la va a tirar.
¿Pero le agregaste este?
Yeah, sorry, I forgot to add that line.
Sí, son los típicos errores.
No, sorry. I didn't forget to add that line. I forgot to remove the PLT in the subplot part. Because I imported the subplots.
Funcionó.
Okay.
Hermoso, gatito hermoso, ya. Ahí está. Can you recover the original?
Hay que sacarle el furier al gato.
Ya.
Ok, ya.
Entonces, con esta cuestión.
Lo estoy pasando como a cuaderno para ver si se me ocurre alguna idea de cómo empezar a desarrollarla.
Why is no one talking here?
What is the error we have to correct this?
Yes, that instead of Y, original is just Y.
Okay.
Yes, and at that line there, at subplots, you need to remove the plot dot. After the U equals blah blah blah, there. The first line here, there. You need to remove the plot there. Yeah.
Okay.
And that U underscore corrupted is just Y. That should work now.
Okay.
Sorry about that. So you need to download the cat images and then you need to run the second part. But it's already working.
Okay.
¿Que está en pregrado?
O sea, ya me licencié. ¿Ya? Y estoy haciendo el título de ingeniería.
¿Y este ramo es como un electivo para ti o...?
¿Qué cosa?
¿Este ramo es como obligatorio o como un electivo para ti?
Me lo recomendó Daniel. Me dijo que Carlos Silong y Daniel Hurtado desarrollaron este ramo. Y Daniel me dijo que era un muy buen ramo para tomar y desarrollar la matemática que estaba atrás de todos los trabajos que iba a hacer.
Ay, tú querías el magíster en ingeniería... ¿Cuál ingeniería esa? ¿O en general?
Estoy en magíster de ingeniería... de ingeniería normal, de ciencias de la ingeniería.
Ah, ya.
Lo que aprendí de la clase pasada, de la ayudantía pasada, es que hay que escribir eso de forma
matricial,
como
¿no?
Matricial bonita.
Yeah, but in this case, the total variation is already defined, so you don't need to define the total variation.
¿Qué?
The total variation is already defined by the hint using cp.tv already does the job for you.
Wow.
Yeah, you don't need to define it.
Okay, perfect.
Okay.
That will be too difficult.
Sí, no, ya me está preguntando, cuestionando la vida. Entonces, TV va a ser cv.tv. Sí, TV de... ¿Cómo se hacía con Google Colab? ¿Ver las ayudas? ¿Poner el mouse arriba, no?
Shift tab. Or control space, I don't remember exactly. Control space maybe?
No.
Let me see. Or shift space? Something with space, I don't remember exactly, but inside the parentheses.
Adentro del... No.
It's something with a... I think it's control space, but your browser is mapping it to another thing.
Puede ser. Bueno. De X.
Yes, but you need to define X first.
Bueno. Hay que definir X. Tenemos...
How are you doing here?
I'm trying to understand how to use the CP library.
Yes. Well, first you need to define the variable x. So you need to define x equals to cp dot a variable. Yeah, but variable with the caps in capital. The first letter.
Yep.
Yes, like that. And inside the parentheses there, you need to define the size of the... Yeah. And you have your rows and columns already defined. I think you need to put shape instead of size. Shape. Shape, yeah. And instead of square brackets, you need to put parentheses. Because you're passing a tuple. Yeah, that's correct. And now, instead of minimizing the all of that, you minimize cp.tv. And tv of what? Of your variable. X. And now you need to remember how to add the constraints. So previously we didn't have constraints, so you will not find in there. But try to see in the help of the functions and see where to add the constraints. It doesn't make sense to add the constraint in the objective function, but probably is in the problem. And there you put your constraints.
I've been looking how to write the constraints. and you have to add a square bracket. And inside, put your equations that you want to use.
Yes. And in the hint, I already said that you need to use cp.multiply, so try to use that. Yeah, but multiply is without the caps. The caps are only for the objects. And what you need to multiply? The matrix U and X.
U and X.
Mm-hmm.
You're missing an S in the solver.
Yes, you're missing an S.
It's CPCS, I mean SCS. Below, right below.
SCS, okay.
There you go.
And I'm not completely sure, but I think you need to put 2 equal signs. Yep. Try to run everything. Okay, so solver does not go there. Solver goes in the solve call. The solver, it makes more sense that it goes in the solve function. And it's thinking, so it's doing something. That's good. Taking a while, but it's doing the correct thing. I'm pretty sure. But it will not plot the solution.
No.
Because to get the solution after it's done computing, you need to use the variable x and see the value property of that variable after it's finished solving. So you need to do x dot value, and that's the thing you want to retrieve as your solution.
Okay.
Okay, so let it think a little bit, and I'll go to the other room to see how they are doing. How are you here?
Ahí, SCP, import CVXPY ACP, tú no lo tenías en la... Y después...
No se le escucha nada.
Yeah.
No.
Benjamin, no one is understanding what you're saying. I muted Benjamin.
Pero estábamos, porque la idea es subirlo los hints que dejaste acá, ¿cierto, Carlos? Del CP, CPTV y CP multiply and solver CP. Y tirando ese.
Share your screen, Javiera.
Ya. Ya. I don't know if. No sé si está bueno.
Okay, so you're trying to.
Y después.
Okay, so the first, just to correct, the first thing you need to do is to define the variable x. So that's our first step. So x is equals to cp dot variable. Variable with the first one in caps. The first one needs to be mayúscula. Variable. And after that, you need to define the shape of that variable. So you are missing the parentheses. And inside, you need to define the shape. And the shape is, well, you already got in the previous cell the number of rows and number of columns of that variable. That is called rows and cols. Or you can just use y.shape.
How? Can you repeat, please?
The easiest thing to do there is to write y.shape.
Why that?
Y, no, y is the y.
Why?
Dot.
That, shape.
Shape.
This?
So the second line, what you're trying to do is to minimize or to define your objective function. And there you have minimize something, but you're not trying to minimize that now, so you can remove all of them.
Yeah.
No, only the part inside the parentheses.
This.
And now what you're trying to minimize is the cp.tv, that is the total variation of your variable. TV.
TV. Yeah. TV. The total variation.
Of, or parentheses, of x.
This?
Yes, that's correct.
Yeah.
And now you need to define your problem.
Yeah.
So your problem equals to and inside the problem, sorry, you need to define not the problem in mayus. Instead of problem, name it prov, but in minúscula. And you need to do cp.problem. Why you need to use the minúscula? Just because.
No.
What?
No. Why are we using the cp dot variable?
Where first, to use CVXPY, you need to define the variable you're trying to get or to optimize, and your variable that you're trying to get is x. That is the image of the cat. That's the final result, the image of the cat. And you need to define the shape, and that's what you do with y.shape. Basically what you're telling there is that to create a variable that has the shape of an image. And in the second line, you're trying to minimize the total variation of that image. And in the third line, you're trying to define the problem.
Okay.
And the problem has two parts: the optimization or objective function and the constraints. And then you try to solve that problem. So first, to define the problem, you need to do cp.problem, now in caps. cp.problem, but in caps, because the problem here is no, problem and with caps.
With caps?
Yes, mayúscula.
Ah, yeah. Here?
And in singular,
okay.
problem, not problems. And inside, you need to define the objective function. So you put obj, yeah, and that then comma constraints. And then you need to define the constraints. And yeah, and what are your constraints? If you go back and try to see the constraints are the part that are at the right of the subject 2. A little bit more up.
No, it's my.
Not there.
No, it's there.
Okay. Here. Okay, so there you have your constraints. Subject 2, u times x is equal to u times y.
Here.
So you need to do that, and as you can see, you have a multiplication of that matrix U and your vector X, and you want it to be equal to that matrix U multiplied by your other vector Y, that is your date. And the hint says that you need to use the cp.multiply function. So try to write that.
Yeah. In this sería aquí.
No, but you're missing the u that inside multiply. You need to put u, comma x. Yes, but u is in caps because it's defined in caps. No, caps, mayúscula. Yeah, and that needs to be equal. No, that needs to be equal to the same, but with the y.
Yeah.
But outside.
Is it correct to put constraints equal cp multiply ux equal again or not?
It's not correct because you need to put a square brackets. But the other thing that is incorrect, but she hasn't done it yet, is that instead of comparing with just one equal, you need to compare with two equals. So in that part there that you're having your cursor, you need to add a square bracket. Corchete.
¿Dónde? Ya me perdí.
There.
Okay, perfect.
Because you can have more than one equality or inequality. So you have a list of equalities or inequalities.
¿Aquí?
Sí, como que parece que es corchete cuadrado y adentro tenéis que colocar cp.multiply y adentro del multiply solamente tenéis que colocar el u, x. Cierras ese paréntesis y colocas igual cp multiply.
Exactly.
Ya entendí, pero ya entendí.
But instead of putting just one equal, you need to put two equal signs, because two equal signs means comparison, or you're comparing things. If you put just one equal sign, what you're telling in Python is that you're defining something as the thing in the right.
Y tenéis el último paréntesis, hay que borrarlo. El último. Ese.
No, that's correct. you have an error there because in the second multiply you need to put u, comma y. U.
Ah, aquí.
Sí, debería ser una U
U.
y una Y.
And now you need to solve your problem. And how do you do that? Problem.solve. No, problem.solve. Or here is called prof. Sorry. No. Prof.
No.
Prof.solve.
The problem is prof.
You're calling the problem specified before. And parentheses? No, just solve. Solve. Parentheses. And now you define the solver. And the solver is equal to cp.csc.
Ah, okay. ¿Y cuál? Ah, eso.
And run that. That should give you the solution.
Magia. sé que corre.
No, it's working. I have hope. And after that, to retrieve the solution, you need to do x.value. X.value is your solution. After that line, that cell is finishing, well, it finishes the solution. Okay, so let me see how the other group is doing. Okay. Did the solver return to you the solution? Yes?
Yes.
Perfect. And well, you already started the second part, but the second part does not need an introduction. So if you want, just finish the second part, the second activity. The second activity is very interesting because it's actually a method that is used by detectives to find the homes of serial killers. And they do it by solving an optimization problem. So you'll be a detective for the second activity. Try to solve the second activity. And that serial killer there is real, by the way, and the locations of the murders are real as well. The data and the serial killer are real. You can Google them. It's real data. Okay, did it solve? Not yet.
It took a long time.
Yes, but the other group did the same and it gave the solution back, so it should work. Now, meanwhile that is solving, you can go the next cell or create another cell to plot the reconstruction or your solution and compare it with the image of the cat. So try to plot the...
I have a question, Carlos. When you do this code, the prob.solve and all that, get a number.
It gives a number?
The coordinates, where are they?
What, in the second activity?
No. The X.
Okay. So the number is the number that it gives is the value of the objective function on the found minimizer. To obtain you need to do that. X that value is your image, and you need to show that image.
Okay.
Okay, so that's the solution, but you're not getting anything with that. So instead of just putting that, do from matplotlib import imshow, and so you put from matplotlib dot pyplot
Whoa!
pyplot import imshow. And now imshow the x dot value im with like image im. It's like show me the image. So,
Or you can run the cell that is the cell 16. Javiera, Javiera, ¿cierto la que está mostrando pantalla? Si corres esa celda, córrela.
it's already imported? Oh, you don't need to import it then. Yep. So you don't need to import
Ahora baja
the
la
thing.
celda 18. Ya, borra la primera línea. Ya, y pon imshow.
Imshow.
Borra xvalue. Imshow, abre paréntesis. Y ahí pon x.value.
And then you need to put
comas,
cmap.
cmap igual entre corchete, entre
Comillas.
estoy haciendo el gesto con las manos, comillas. No corchete, comillas.
Remove the square brackets. You need to define
es igual a entre comillas gray. GRAI. GRAI.
Gray, like gris
Gray.
in English.
De gris. Y
But,
no es cmap igual a.
Now rent.
Córrelo. Y tiene el gatito.
Do you understand what you just done? You restored or reconstructed the image almost identically to the original one based on an image that was corrupted. The image had letters on top, and you basically remove the letters and recover the original image.
Es mágico.
Javira is in shock. She's not talking anymore.
No, estaba hablando sola, ya, pero sí. Se supone que en ese caso, mi imagen que está corrupta, la transformo donde estas letras que están negras las pone en el color que deberían ser del gato y las partes blancas las deja blancas, o es como...
No, think as you only have the corrupted data, the image at the middle. You only have that. And what your optimization problem is doing is that in white, the letters in white is trying to estimate what are the values that are most likely to be there.
Okay.
So it's trying to...
de la imagen que ya tengo, o sea, como del fondo.
Yes, based on the background, it's trying to recover what is inside the letters.
Yeah, super.
Have to have available at least 75% of the picture. I mean, based on the sample theorem or something like that.
This is a non-linear optimization problem, so it can skip a little bit of the sampling problem. But yes, obviously, if the letters are too big and you don't have enough information, for example, if the letters were too big and there was too much white space, you obviously cannot recover what's inside. But here the letters are very thin, so you can recover the image very accurately. So this problem is not based in the restrictions of the sampling problem, but it's doing something similar. Basically, you have samples in every part of the image, but the letters. And well, I don't have another image And I don't have another corrupted image to show you, but if the letters are bigger and the missing data is more than in this case, you'll obtain a solution, but it will not be as good. So now that you already done the first activity, try to do the second activity. The second activity is very interesting because it's based on real data of a serial killer that was called the Boston Strangler. And basically what you're trying to do in the second activity is to find the home of the serial killer based on the positions of the murders. And if you scroll down, you can see the activity.
¿Había que hacer algo, Carlos?
You need to do the second activity now.
Ah, ya, okay.
And the second activity I was talking is about a serial killer, a real serial killer, and the positions of the murders in a map. And you're an FBI agent that is trying to find the home of the serial killer.
Carlos, de A and B, la A y la B, ¿son lo mismo que de lo que está arriba?
No. The A and the B are defined in the cell after the activity 2.
Sí, pero esa A y X, ¿puedo compartir pantalla, Jai?
Sí, obvio. Sí.
Ya está viendo esto, no. Ya, esta A y B, ya son estas mismas.
Oh, yes. Those are the A and B.
¿Y existe una función de CVX que tenga esto directamente? ¿O hay que escribir la norma de bla, bla, bla?
I think there's one. I'm not completely sure, but I think there's one that is called a sum of squares. So you can do something like that, yeah. Because basically the norm of a difference of vectors is the sum of the squares of each coordinate. So you can obtain it by using that function. So I'm quite sure if you do cp.sum of squares, sum underscore squares, you can do it.
Acá mismo el x sub i es de salvo sites.
Are all the murders. The position of the murders.
Oh, qué entretenido. Y inner product, el producto interno, también existe en CVX, ¿cierto?
Yeah, but you can use the at notation. Arroba.
Ya. Sí.
A at x.
Entonces, si x es cp.variable de ¿cómo se ponía el shape? Shape.
That's real data, by the way. You can Google it.
Oh, genial. Shape 2,1. Y sería el problema, no, es el objeto, es igual a cp.minimize. Todavía no me acuerdo cómo se escribe todo esto, así que a copiar y pegar la mejor forma de no cometer errores.
That's the idea.
scp.sum.
TV. Ya.
I think there's the function called sum underscore squares.
Sí, es lo que estaba buscando. Ya que acá encontré hartas cosas de SP y salía uno que era como la sumatoria de eso. No, pero esa es la norma.
Yeah, that's not it. Sum of squares there.
Sum squares. Perfecto.
Yep, that's the function you want.
Sum squares de la norma de las cosas. cp.norm.
No, the sum of the squares already does everything.
Sum square, just that.
Yes, yes, because the norm is also a summation of squares.
Toda la razón. Sum squares de x menos ¿cómo se llama la variable? De salvo size.
Yeah, but first try to see the shape of the variable.
Pero va haciendo uno por uno, ¿no?
Yes, but the salvo size could be of size n, 2 instead of 2, n, so that would not make sense. See the shape of the salvo sites.
Sites. Shape.
No.
No.
It was correct. You only need 2 numbers because 2 numbers define a position. But what I was talking about was to check the shape of the variable the salvo sites.
Lo agrego acá. Se ve con shape. No.
The salvo sites that shape.
Shape.
Oh, you need to run the salvo before.
Ahora sí.
13,2. Yeah.
13,2.
You see, you need to transpose then. Before doing the subtraction, you need to do the transpose of the salvo sites. Or there you can put dot t.
Sí, es lo que me está intentando acordar. Punto T para transponer directamente.
Yes. I'm not sure, but I think that works now.
Veamos si tiene algún error. Tira error.
Cannot broadcast the dimension. Oh, yes. Okay, so you forgot to redefine the shape of the variable x.
Toda la razón.
No. That needs to be 2, 1. Because it's only 1 point. Yes.
2,1 de salvo sites.
Transposed.
Y ahora no debería tirar error. Vuelve a tirar error.
Oh, probably CVX cannot do that subtraction. The subtraction, like the point-wise subtraction. Maybe it has a function that does that. See in the CVX website if you have a subtraction that does the stuff point-wise. Or an addition. But something that it does the things point-wise.
Sí, lo podría ser de los primeros, ¿no?
Yeah.
Y no existe como se hacía en MATLAB, creo que se hacía como
there. No. There in the see the documentation again. At the left, you have a section called Atomic Functions, and there's a part where you see element-wise functions. So here you can.
Y no está.
No, but probably after that. After that, you can see the. Or no? Before?
Pero podemos hacer...
There. cp.sum, but keeps dimensions true. I think that should do the stuff.
Esto. Vamos, tú puedes, programita.
No. Let me think.
Bueno, siempre podemos hacer zoom de cp.norm.
Yeah. But the problem is that you need to do the norm for every point. So you cannot do it. Let me.
Sí. Pero siempre se puede poner un.
Let me. I'm requesting the control. Can I do it? No.
Sí, obvio.
Here. Instead of that.
Y poner una ahí y ponerla dentro de un for, ¿no?
Instead of. Yeah, basically that, but yeah. But with a list comprehension. So here. For in range,
len
the I messed up. That. Yeah, I think that should work.
Debería. Sí, debería esta vez. Le borramos el 1.
Perfect.
Listo.
Yeah, but now you need to define the problem because you're missing the constraint.
Sí. Creamos el constraint al tiro. Constraints. Arroba X. Esto se hacía con esto. ¿Sí?
B.
Entonces el problema es igual a cp.
¿Era problem con mayúscula?
Sí. Gracias. De el objeto y el constraint. Y ahora solve.
Now you need to put the constraints as constraints equals, and then you put the thing in the square brackets.
Pero esto es lo mismo, ¿no? Porque si va a decir cuáles constraints es esto.
I'm not sure.
Si lo hice.
It works.
Lo
I'm
hice
not
antes,
sure.
Ya, y me funcionó.
So then it works. No problem. And then problem.solve.
Ya hay que ponerle el cp.
No.
Solver.
No. It's the default solver is okay for this problem.
Oh, rápido.
Yes, and now plot the solution. Basically copy paste the map that I already done previously and add your solution. Yeah. And you need to add another line that says plot and you add the solution point.
Si lo agrego acá, lo hiciste con labels, ya. Plot de x.value.
But the first element of that.
Del primer elemento.
Coma.
Ahora que no necesito las ayudas, x.value, el segundo elemento, y corrámoslo así. Y label igual más que label, agregarle algún punto verde circular. Y ahí está.
And that's your predicted position of the home, and it's very close to the actual home of the person, of the serial killer. So that's an actual method to find the position of a serial killer, because that is based on the premise that the serial killer does not want to travel a lot from his or her home, and as you can see here, you can find a position very close to the actual home of the serial killer. That's the predicted home. Yep.
No. Ahí está la casa. Si hay una casa ahí y hay alguien viviendo, ese gallo los mató todos. FBI.
Yep. So let's finish the tutorials for today. Let's join the groups and see if someone has another question, and let's finish.
Y en el grupo hay como 70. Entonces...
Did you manage to find the home of the serial killer?
Yes.
Yes? Did you find a point that was very close to the actual home? Can you show it to us?
Yes.
I think I need to enable... oh no, it's okay. You can share the screen. Just to make emphasis in this, the problem of the serial killer had actual data of the places of the murders, and the home and everything is correct. That's a real serial killer, and now you can be part of the FBI and try to predict the home of a murder. Are you sharing your screen, Diego? Someone is sharing their screen?
No. I will share my...
Okay. Can you show us the home of the serial killer? That one? And where was in the map?
I don't plot the...
Yeah, but the correct place is, you can see there is 19,18, and your solution is almost
13.
Yeah, but it's close.
Yes, it makes sense because most of the
points are there. Yes, it makes more sense to estimate.
The conclusion of this is that if you want to murder a lot of people, you have to murder in a sector that is far away and of your home.
Yes,
and that may...
Yeah, that will confuse all the agents, the detectives. No one will suspect you if you do all the things very far from your home. Yeah, and well, that's the conclusion of this TA. You are already able to restore photos of kittens and find serial killers. So that's why mathematics are so powerful, and you can do useful stuff now. And we'll end the recorded part of the TA, and we'll finish with some doubts. Okay.